Okay, last time we went through the syllabus and the term project guidelines. So, and these things are uploaded on the Blackboard and you should be able to see them. So today we will start with the topics of the course, and our format will be when you start any slides, you will see at the first page the chapters from which these slides are taken. Okay, and when the book is not mentioned, it is this book, the textbook, which is mentioned in the syllabus. Okay, the syllabus mentions this as the textbook. So in the other slides you will see no book is mentioned, that means this one. Okay, so you can go and read, which you never do anyways. Yeah, the other thing which you will commonly see is I showed you the course outcomes which we are trying to fulfill in this course. So in the slides you will see which outcome the topics of the slides are covering. Okay, so these topics which are in these slides are covering the basic concepts of traffic engineering, the basic concepts and principles of traffic engineering. Okay, so let us begin. So we start with the definition of a traffic stream. Okay, a stream is, you may have heard the word for water streams, right? Okay, if you have gone to the water resources lab, I have not gone there in UOB, but in our days in Pakistan, there used to be a stream there, so they will flow the water and they will show you how the waves are being made and what is happening with the silt and sand and so on and so forth. Do they do that?
Doesn't work.
Huh?
Doesn't work.
But there is something like this, right? Huh?
Should be.
Should be, okay. Anyways, so a stream means what? Flow, right? So we have data stream, water stream. So when I say data stream, what is flowing? The data. And when we say water stream, water. Okay, so traffic stream, traffic is jammed, right? Huh? It doesn't flow. Agreed or not? Okay, so this is wrong then, right? For the sake of the class, we will assume there is a traffic stream as well. Okay, forget about the 7 p.m. and 5 p.m. 7 a.m. 5 p.m. Okay, so traffic stream means flow of vehicles. Traffic is made up of what? Vehicles, right? Okay, so a traffic stream is made up of vehicles mainly. For the time being, these vehicles are driven by drivers, us, unfortunately, right? You all agree, right? Better fund Elon Musk to build cars without drivers and give it to us for free. So we can sleep during the drive. Okay. So our traffic stream is made up of vehicles. Vehicles are governed or they are controlled by the drivers. By the way, the driverless vehicles also have to comply with the expectation of the road users. Okay. The driverless vehicles, even if the driverless vehicles come into the traffic stream, they have to accommodate for the behavior of the road user, because maybe the other car is driven by the driver. Okay, so the driver behavior will still affect the traffic stream. Even if you are sleeping, your car is driving by itself, even in that case, you have to accommodate for the other drivers or road users. Okay, so the effect of road users and drivers will always be part of traffic stream. Clear? Okay. So we have to consider the driver behavior. We have to consider the type of vehicle, the characteristics of the vehicle. And other things we have to consider is the physical elements of the road. How many lanes you have? Is it a straight road? Is it a curved road? Is it an upward gradient, a downward gradient? Is it a bridge? And so on. Clear? These are part of the physical elements. Is there a signal ahead? Is there a roundabout? Is there a stop sign? Okay, all these things are part of the physical elements. And the general environment which is around the road. Okay, environment means what is around the road. For example, like what? What is around the road that affects traffic stream? The barrier. Pedestrians, yes. What else? Huh? Weather, yes. Okay. Huh? Weather. Okay. The lighting conditions and so on and so forth. Okay. The trees, the buildings. Okay. All these things affect traffic stream. There's something which we call as the land use as well, which is the type of buildings you have around the road. Okay, so there could be small villas on the side of the road, and there could be big buildings, and they may have the same space. So the villa and the building are constructed in the same space. Their area is same, but the type is different. So a villa has a different effect. I'm talking about the driver, not to the people living inside the villa. Obviously, there's different. But the villa has a different effect on the driver as compared to the building. Okay, the wall has a different effect. The barrier has a different effect as compared to a tree. Got it? Okay. Now, when we study traffic stream, we have to keep in mind that they do not exactly replicate. The traffic behavior cannot be duplicated in terms of time and space. So you cannot say that on this day I found traffic flow for 1 hour as 2000 vehicles per hour. Okay, so in the same hour next day the same should happen. There is no such thing like this. Okay, the variation is expected. The variation in traffic flow is expected. Okay, so the flow will change. Obviously the flow changes the speed as well, and there are other things which will change as well. The speed will affect your travel time and so on. Clear? Okay, so traffic stream behavior does not duplicate in terms of space and time, and this is expected. Okay, this is expected. So if you get one value for 1 day which is very high, and on the same road on another day on the same time the value is very low, this can happen. Okay, and later on in the course we will discuss why it does happen. Okay, like the extreme changes, the extreme variations, it has then special reasons. Okay, but as for the normal variation, the regular variation, the routine variation, okay, so there are two main reasons for these variations. Okay, the variations which happen every day, every hour, okay, which are considered to be regular, routine, average. Okay, they are supposed to happen, and they are variations in individual vehicles and variations in individual in driver behaviors. Okay, what do we mean by vehicle characteristics? The type of vehicle, for example. Okay, a very small example, the type of vehicles we have in Bahrain will not match the type of vehicles we have in, for example, in Pakistan, okay, or in UK or in some other country. The mix is different. The vehicle properties are different. Okay, you know the size of Bahrain, for example. Okay, even Saudi and Bahrain, that the quality of the vehicle is not the same. Okay, because there 1,000-kilometer trip is like every week. Okay, and here 1,000 kilometer can mean one whole week. Okay, 1,000 you may spend or you may drive for 1,000 kilometer even in the whole week in Bahrain because of the size. In Saudi, maybe you will take one trip going to Riyadh and coming back. It will be 1,000 kilometers. Okay, so you get the idea now. It will have some effect on the vehicle, right? Okay, you can see now two countries which are very close to each other, but the vehicles will not be the same because they are going through different types of drives. Clear? Okay, so vehicle characteristics, vehicle mix, okay, the percentage. If you are going towards causeway, for example, But if you are going in the Sitra area or in Salmabad area, okay, you can feel the mix is changing. You see more heavy vehicles. Got it? Okay. And in other areas, maybe if you go towards Jufair or Ali or something like this, then the heavy vehicles are less. Okay. And there are some areas in which maybe the bikes are more. Okay, and so on. Okay, so the mix of vehicles can change, the quality of vehicles can change. Okay, and driver behavior. Okay, you two came together. You came together to university. No. See, they were coming for the same class, but the behavior is different. Okay, this one took 15 minutes extra. Fine. Didn't find the parking. Come with him. Okay, but you see we know the drivers are different, right? Okay, some drivers take more risks, some drivers are more cautious, they are more careful. Okay, some drivers speed up on yellow, some drivers will try to stop on yellow. I'm still trying to find those. Nobody. Okay, clear? Okay, the same driver, and there is a variation in the behavior of the driver from time to time as well. Okay, so driver behavior in the morning may not be the same which is in the evening. The trip which you are taking to go for the class, or trip I'm taking to come to the university, my behavior could be different as compared to when I'm going for shopping or something. Got it? Clear? Okay, I'm coming to the university, I'm relaxed, right? What if I miss 15 minutes? Nobody cares, right? Good thing. You can relax for 15 minutes more. But you get the idea. Clear? So these things are normal. These two things are normal. Okay, they are not considered extreme reasons or they do not cause extreme variations, but they will cause some variation. Okay, so you will see traffics on different countries on different roads is different because of these reasons. Okay, and they are considered normal. Okay, they are expected. Now you first of all, in the textbook and in the slides, I keep on referring to the textbooks, at least you know when I say what is written in the textbook. You will not read it, I know. At least I am telling you, this is what is written in the textbook. When they say traffic facilities in the textbook or in the slides, they mean streets and highways. Traffic facilities means streets and highways. Clear? Okay. On the broader level, it can also include parking spaces as well. Okay, so parking spaces are also part of traffic facilities. Okay, so this is the term they use. So when they say types of traffic facilities, they mean types of streets and highways. Okay, they mean types of streets and highways. What are the types of streets and highways? Tell me. Local, yes, and international, right? Yes, local and arterial, collector, okay, urban and rural, okay. This is on the basis of purpose of the highway. We call it functional classification. I will show you later on as well. This is on the basis of function of the highway, purpose of the highway. We have another classification approach which is on the basis of type of traffic flow. Okay, these two types which you see on the slide here are on the basis of type of traffic flow we have. Okay, so those were on the basis of purpose, this is on the basis of type of traffic flow. Okay, so you can divide the same thing using different approaches. For example, the students, I can divide you in terms of male and female. I can divide you in terms of batches, right? You are the same students, right? But the division can be different. So this is on the basis of traffic flow type, because we are studying traffic engineering, right? So that's why. So on the basis of type of traffic flow, we have two types of traffic facilities, two types of highways, uninterrupted and interrupted. Okay, uninterrupted and interrupted. Interruption means what? Yeah, intersection. It's a good thing you are reading from the slide. Very good. Keep it up. Yeah. Intersection does what? Huh? No. What? Like if you are going on the highway, you see an intersection, you have to do what? Stoppage. Okay. So this is the main difference between interrupted and uninterrupted. Okay. By the way, if you are reading from the slide and give me the answer, it will save a lot of time. Okay. I don't mind. So you can do that, but normally you don't do so. Interruption means there are fixed stoppage points on the highway. The points on which most often you have to stop. And one of the prime example of that is an intersection. Okay, an intersection. Usually you come across an intersection, whatever type of intersection it is, most of the times you have to stop. So that causes an interruption. Okay. So interrupted has the interruptions, uninterrupted doesn't have the interruptions. Clear? Yes.
Now the walks count as interruptions.
Yes. Yes. You don't like stopping on them, but like you should. And it will have less cars per year than Bahrain. So yeah, when we say interruptions, okay, for this reason, for classifying the highway, we mean the interruption which is fixed. Okay, like the roundabout, like the signal, they are fixed. Okay, they are at this location and they are there. Okay, they don't move. Okay, it's not like they are working in the morning and not in the evening. It's not like this. Clear? So these interruptions should be fixed. Okay, and these interruptions are external. So at intersection, there is an external traffic which is crossing you, right? It is not part of your highway. It is not part of your stream. It is not part of your traffic flow. Okay. So these interruptions we are talking about, they are fixed and they are external. Clear? Okay. If there are any other interruptions which are temporary or which are because of traffic itself, then they are not counted as, you will not change the type of highway because of that. A highway does not have any intersections. Okay. But the Ministry of Work guys come and they have to close the highway for 2 hours because they are doing some maintenance work. Will it change the type of highway? No. Clear? Okay. A highway which does not have interruption is said to have full access control. Okay. I told you at intersections we have crossing, right? The other traffic is crossing you. Okay, that's why we have the interruption. Okay, so because that traffic has to, now what is the meaning of access? Access means the entry point. So that traffic has to enter or cross your highway. It is crossing means entering and exiting, right? Or it is taking a turn towards your highway. So in both cases it is access. Okay. So when we don't have any intersections, that means access is controlled. Okay. Control means it's restricted, completely restricted. Okay. Nobody can directly enter or cross your highway. This is what it means. Okay. Because if you allow access, then you have to allow interruption as well. Otherwise it is not safe, right? If you allow the access, then you have to stop your side. Clear? Otherwise it is not safe. So we have different types of highways which come under this category. Okay, so uninterrupted highways have subcategories as well. One of them is called as freeways, other one is called as rural two-lane highways, and there's another one which is called as multi-lane highways. We will talk about them in detail later on. Okay. Yes.
Can you repeat please the point of access?
Access means an entry point. So when there is an intersection, the traffic, I stop you, so these people can enter and exit, right? Okay, so crossing means entry and exit, or they will take a left turn, which is basically an entry. Okay, so if I don't give an intersection, that means nobody can come like this. So access is controlled. Control means restricted. Okay, the meaning of word control means restricted. Okay, blocked. Blocked. Okay. So if you are not allowing any external interruption, then the traffic flow mainly depends upon the highway itself. There is no external factor, or there is no external traffic stream affecting this highway. So whatever is happening on this highway is because of its own traffic and because of its own highway conditions. Okay? Clear? So if you see, for example, there is a traffic jam on this highway, uninterrupted. Okay? The usual perception is, if you don't give any intersections, there will be no traffic jam. It's not true, right? You go in the morning to any big major highway, you see traffic jam. Clear or not? Huh? The national days are coming. So you go towards Formula 1. They close all the intersections, right or wrong? But still there's traffic jam. And you guys enjoy that, right? Huh? Not normal. Huh? Only normal guy. Okay. But the point is that if you see the traffic jam, it's because of the traffic on the highway is very high. Okay. If you see the speed is low, maybe the design speed of the highway is low. It's not because of something else. Okay. On the other type, the interrupted flow highway, you may see traffic is stopped, not because of this highway, but because of the access, because of the interruption. Got my point? Okay. So interrupted flow, we already know now what it means. You have a fixed external interruption. Okay, and these external interruptions can be any of these, and most of these are related to the intersections, right? Signals or intersections. Stop sign, intersections. Yield or give way sign, intersection. Roundabout, it's not mentioned here, it's an intersection. If there is nothing on the intersection, but the intersection is there, like on the local streets, and most of the local streets, you may not see any signal or any sign or any roundabout, but there is a street crossing, so it will be considered as interrupted. We are not looking at the sign, we are looking at the interruption itself. Okay, the interruption is the other street, not the sign. If I remove the sign, it doesn't mean nobody will come from the other side. Clear? So the interruption is the street itself. Similarly, you can have entries and exits from parking areas. Okay, these are also considered an interruption, because these people who are entering and exiting are from the highway, right? From the street. So when they will enter and exit, we may have to stop for them. Okay. Driveway means the parking is somewhere inside, like you're coming out of the mall. Okay, so you come from the parking area, then there's a small a lane in which you drive before you come to the street, right? So that small lane is a driveway. Clear? Okay. Or it can be a curb parking. Curb parking means it's on street, it's on the side of the road. Okay, so this is your street, and on the side there are parking spaces. Okay, it's not covered, it's not inside anything, not inside any building or villa or something. Okay, but the concept is same. People will come in and go out, and they will interrupt. But it can be any other land access. So you have a land beside the road, you have a building beside the road. Any access point given to those buildings or those lands will create interruption. Okay, and what did I say what access means? Access means what? Huh? Entering, right? Access means, okay, fine. Exit, entry, yes.
Are ramps interruption?
No. Yeah, ramps are not considered. We will talk about them later on in another lecture, but these interruptions, they are direct. Like you are directly entering the road itself. Okay? On the ramp, you don't have the right of direct access. Ramps do not give you the right of direct access. Get my point? Okay? From an intersection, you take the left turn, you are on the highway. That's it. There is no merging. On the left, there is merging and diverging and so on. Okay. So when we study traffic stream, we have to study certain parameters, certain properties of traffic, and these properties can be divided into two types. So this is now types of traffic parameters, traffic characteristics. Okay, those were types of what? Interrupted and uninterrupted. Types of what? Huh? Traffic flow.
Highway traffic.
Those were types of highways based on traffic flow. Those were types of highways based on traffic flow. Okay, and this is now types of traffic flow properties, traffic flow parameters, and they can be macroscopic and microscopic. Okay, you know microscope, right? So microscope, which one is bigger, macro or micro? Huh? Macro is bigger, right? That's why we have the store macro, right? We don't have the store micro. There's a store macro, right? No? Okay. You need to go out more. Okay. But macro is bigger, right? Okay. So bigger means you are collecting data about the whole traffic flow, the whole traffic stream. Okay. That is called as macro. Okay. And if you go in more details, then we call it micro. Okay. So if you are looking at the traffic flow complete, it's macro, bigger one. Okay. Scale is bigger. Okay. If you go to a smaller scale, then we call it micro. And if you go inside traffic flow, inside traffic stream, a traffic stream is made of what? Huh? Vehicles, right? So micro means you are looking at each vehicle now. Okay. Macro means you are looking at the entire group of vehicles which are in the traffic flow. Micro means now you are looking at each vehicle, which is each part of the traffic flow. Clear? Okay. Yeah. So these are the parameters which we will study in this course. There are 3 for each type, macro and micro. Okay. So macro parameters are volume, rate of flow, speed and density, and micro are speed, headway and spacing. Okay. Now you can see there is something which is common in both of them, which is speed. How can it happen? How can we have speed as macro and micro both?
For macro, we take the average speed.
Macro you will take the average, and micro you will.
Individual.
Okay. So moving on to macroscopic parameters, we have the first one, which is volume and flow rate. Actually, there are 3 things. All of them have the same definition. Okay. So all of them are the same type. One of them is called volume. The other one is called flow. The third one is called rate of flow. Volume, flow, rate of flow. Okay. For all 3 of them, the definition is number of vehicles passing a point, lane or direction in unit time interval. So if you remove the brackets, this definition is same for all 3 of them. Clear? Okay. Now, if your unit of time is a day or an hour, if your unit of time is a day or an hour, then we call it a volume. Okay. If it is less than 1 hour, we call it flow. Okay. And the third one was what? Rate of flow or flow rate, right? So it's a rate. It's a rate. Okay. Rate of what? Rate of flow. And what was the definition of flow?
Stream.
No, flow. Very good. I forgot myself. Yeah, what was the definition of flow? I just mentioned this flow, the one which is written here. What is the difference between volume and flow?
The volume is for less than 1 hour.
Yeah.
For more.
Or more than.
1 hour or more.
Yes.
Volume is for 1 hour or more.
1 hour or more.
Flow is for less.
Last semester, right? No? May God help you. Flow is less than 1 hour. Okay? So I am calculating the rate of flow. So I take the value of flow which is for less than 1 hour and I convert it to the hourly rate. That is called as rate of flow. Okay? Clear? So you take the value of flow. You must know flow is for less than 1 hour. Then I convert it to per hour. Then this converted value is called rate of flow or flow rate. Okay? For example, you measured for 15 minutes and you got the value 400. You measured for 15 minutes and you got the number of vehicles 400. Now this one is what? Flow, right? Okay. So if 400 in 15 minutes, how many in 1 hour? What you will do? Multiply by 4. Huh? Multiply by 4, right? By 4?
15 times 4 is 60, which is 60 minutes.
Very good. Okay. So you convert it to 60 minutes then. It was for 15 minutes, you convert it to 60 minutes. Okay. And that value will be then per hour, right? 60 minutes, 1 hour. Okay. Should I call it volume? No? Volume is per hour, right?
No, but you multiply here.
You multiply. Okay. So volume is when you don't do anything and you still have per hour. That is volume. Okay. Volume is per hour without anything. It's actual per hour or more than per hour. More than 1 hour. No problem. Okay. But rate of flow is you took a value which was actually less than 1 hour and you convert it to 1 hour. Okay. So that is called as flow rate or rate of flow. So 400 multiplied by 4 will be 1600. So this value will be called as rate of flow, not volume. Okay. If somebody went to the site and he measured volume he stood there for 1 hour, okay, and he counted vehicles and he counted 1600 vehicles, I'll call it volume. Volume for that hour. Volume of that hour. Now this rate of flow, okay, yeah, I know it's written per hour, but it is actually for these 15 minutes. Okay. I don't remember if I kept the diagram or not. It was confusing. So that can mean that in 1 hour I can have multiple values of rate of flow. In 1 hour I can take a value for 15 minutes, convert it to 1 hour, it will be one value, right? Next 15 minutes I take another value of flow and convert it to per hour. It will be another value of flow rate. Okay. But in the whole hour the volume will be 1. The flow rate can change. Clear? Sure. Okay. So we said volume can be more than 1 hour. Usually the time interval for volume is per day or per hour. Okay, per day or per hour. If it is per day, we call it daily volume. If it is per hour, we call it hourly volume. Okay. In some cases, we use other time intervals as well. Volume can be for the whole year as well. Volume can be for 1 week as well. Okay, still volume. Anything 1 hour or more, still volume. Okay. Daily volumes are used for planning purposes or documentation. Okay. You are planning a new highway in future after 20 years. Okay. You will construct the highway, you plan for it, you construct it, and after you construct it, should remain operating for many years, right? Even 20 years is less. You want the highway to run for maybe 30-40 years. Okay. So in your planning, you are looking at the volume of future after 30 years. Okay. So in those cases, then we use daily volume. Okay. In those cases, we use daily volume. Okay. Why? What's the reason? That it's easier to calculate daily volumes because it will have less variation. Okay, if you go deep, then the variation will be higher. Okay, for example, if you say I want volume for every hour for every direction, more variation, right? You will need more values. Okay, but for the entire highway for the whole day I will have one value. Okay, and this one value, daily volumes are normally combined, okay, for both directions. So basically what it means, and why do we use it for planning purposes, daily volume tells you with a rough estimate how many people will use the highway. Whether they are coming or going doesn't matter. Whether they are coming in the morning or in the evening doesn't matter. On average, these many people will use the highway. Got it? Clear? Okay. How many of them are going by bus? How many of them are going by car? Not important at this moment. Clear? Okay. So when we say daily volume, we basically mean how many people are going to use the highway. Okay. So you have heard about metro project, right? Everybody has heard about it. Nobody has seen it. It's a secret, right? Maybe your kids will see it, huh? Or maybe they will hear about it as well. But if you have those news or reports or plans, whatever, you will see they give daily volume. That we are planning a new project and 20,000 people per day will use it. Okay, it's easier to calculate the per day demand. Okay, so these daily volumes can be now you know that I told you in the first slide, traffic flow does not duplicate. So I cannot say if I say I will start a metro service and 20,000 people will use it per day. It doesn't mean 20,000 exactly every day. Right or wrong? Okay. It will be little bit less, little bit more, right? On some days. So this 20,000 is what? Is basically an average. Okay. So daily volumes can be averaged in different ways. Okay. There are different types of averages we can do for daily volumes. And these are the 4 types which are written here. The first one is for the entire period of 365 days. The first one is for the entire period of 365 days. Okay, and what are we calling it? Average annual daily traffic. Okay, clear? So this is the entire period of 365 days. Keep one thing in mind, it will be discussed later on as well. You will see in some other questions as well. When we say 1 year, we are not strictly talking about 1st January to 31st December. It's a period of 365 days. Okay, you can start from 21st September as well, but then it will finish as 20 September. Clear? Okay, so any complete period of 365 days is enough to calculate this average. Clear? Okay. Then we have the average which is taken for a period of 365 days, but only taking weekdays. Okay. So you observe traffic for 365 days or for a period of 365 days. But in those 365 days, there were breaks because you were only talking about weekdays. So weekends, we don't have the data. So we didn't collect the data. Okay. And then you take the average of those days only. Okay. So what do we call it? Okay. Clear or not? So in both cases, the time period is the whole year. In the first 2 cases, the time period is the whole year. In the first case, I am taking all days of the year. In the second case, I am only taking days of the year. In the last 2 cases, the period is less than 1 year. Other things remain the same. So you can see the first one was AADT, right? And this one is ADT. One A is gone. Which A is gone? Annual. Okay. It could be an average of month. It could be an average of 3 months, 1 week. Clear? Okay. And the other one, D is gone. So average of what? Weekdays. Clear? Okay. So the first two for the whole year. In the first one, all days of the year. Second one, only weekdays of the year. Last two, less than 1 year. Okay. And then again, the third one, less than 1 year, but all days. Okay. And the last one, less than 1 year, only weekdays. Clear? But in all cases, we are taking an average. We are taking an average. So we're looking for an average value. So for example, if we have this example, very easy. Okay, if we have, so the values are given for each month. Okay, and the totals are also given. This is total, all days. This is total only for weekdays. Okay, so if I go for the first value, which was AADT. Okay, so what should I do? AADT meant the whole year, all days. Okay, so how do I calculate the average of the total of all days for the whole year? What do I do? Yeah, which vehicle number? This one. Right? Clear? Easy? Okay. And what should I do for AAWT? The second one, which was for the whole year, only weekdays.
And divide by this.
Sorry, say again.
Take total weekly and divide by days, 60. This number by.
Yeah.
Total 2
Okay. Because you are only taking weekdays, so it will be divided by the number of weekdays. Clear? Okay. You cannot see anything from here. You cannot. It is not possible. Go there somewhere. I can. Next time he will call me from home. I can see, doctor. Okay. What about the last two? What should I do? What we should do about the last two?
Depends on the period.
Huh?
It depends on the period.
It depends on the period. Okay, so the period should be what? More than 1 year, less than 1 year?
Less.
Less than 1 year. What period less than 1 year can I take here?
Month.
Month. Okay, because the data is given for each month. Okay, but it's not fixed. It could be for each week as well, no problem, if the data was given. Okay, but right now we don't have the data. So the last two will be for each month. Okay. Now what will I do for January? If I have to calculate ADT for January, I'll take the total of all days divided by the total number of days. Clear? And for AWT, I'll take the total of weekdays divided by total of weekdays. Okay? Any problem? Can you do it? Will you do it? Very honest. I don't need you in the class. Okay. Any problems? Okay. Now the important thing to remember here is that all these 4 values cannot be done for the same amount, the same time period. For example, AADT and AAWT. You cannot do it for each month. You cannot tell me AADT for January was this much. Okay? Clear? And similarly, the last 2 will be for each month. So you cannot tell me that AADT for January and then you take this over this. It will not be AADT. Clear? Clear? Any questions? Clear? Okay. So hopefully you will remember it till the exam. But are there any problems? You can do this, right? When I ask you can do this, I feel like motivational speaker. You can do this. Everybody says yes. And like those talks, nobody does anything, right? They come to the next speech and right or wrong? I see people know very well. Okay. Then we have the hourly volumes. Okay, so the volume can be daily, then volume can be hourly as well. Hourly volume is used for design. If you have to design a highway, you have to design a signal, a roundabout, okay, a parking facility, you will use hourly volume. Okay. What was the purpose of daily volume?
Design for 30.
Huh?
Design the street for
Any better answer? Somewhat correct. Did I use the word design there? Huh? Documentation or planning? Okay, planning. Okay, yes. This brings me to another point. When you design the highway, so for design we are using hourly, right? To design the highway you are using hourly. Are you designing it for this year only? What did I say? The highway should run for many years, right? Okay. So this should also require future value. Okay. This should also require the value which I have for planning, right? Which I planned for future. Okay. And that value is what? Daily. So when I thought about the highway, this is how it is done. When you start the planning process, you look at the demand. On the basis of demand, you think or you decide whether I need a new highway, whether I need a new bus service or a metro service or an airport or something. Okay, any transportation facility, when you are deciding whether I should do it or not, you do it on the basis of demand, which is your daily volume of future. Okay, so now you decided that we have so much demand on Barron's Road that we need a metro service. Okay, we need a metro bus service. This will bring you to the second step then. Second step is now you give it to someone and you tell him, okay, now do the design for me. Yes.
How do we know the demand for the future? How do we decide?
This is a whole new course. Okay.
Give us the scope.
What?
Give us the scope.
Yesterday I saw in my system a new course. And now I'm asking, what is this course? Nobody is responding me. You will give us this course. Okay. Come to my office, I will give it to you. The books and the lectures. Okay. Or take admission in master. Even then, I'm not sure. Okay. But it will be fun. But the point is, you calculate the demand on the basis of population. I will give you very basic 2 rules. The demand comes from population. More population, more demand. Okay, and the land use. Okay, the activity which you will do in that area. So that area has high population, but it has only residential houses, villas and so on. That area, another area has the same population, but now there are 3 or 4 big malls there. So there is a commercial part as well. Which one will have more demand? Other one means what? This, okay. Commercial, right? Clear? Okay, so these are 2 basic principles on the basis of which we calculate the demand. Okay, but coming back to the point that this is required at the second stage, which is now you start to do the final design of the facility. You already decided I need the facility, you start to do the final design of the facility. Okay, and for that you need the hourly volume. Okay, now you need the hourly volume. And this hourly volume, as we mentioned earlier, all days of the year are not the same. Similarly, all hours of the day are not the same. Okay. So we are looking for what? We are looking for the, must be somewhere here. Yeah. We are looking for what? The peak hour. Okay. In the peak hour, will both directions have the same amount of traffic? No. Okay. So we are looking for the peak hour and the peak direction. Okay. We are looking for the peak hour and the peak direction. Okay. This is the equation we use to calculate our hourly volume required for the design, the future hourly volume. Okay, this is how we calculate the future hourly volume. This is our average daily. How many types of average daily traffic we have? 4, right? Can be any of them. Depends upon your facility, again the land use, and the data you have. The last data which I showed you, the last example which I showed you, it has the data for each month for the whole year and weekdays separate and so on. Okay, so in that case it was possible to calculate all 4 values. Okay, all four average daily values. But in some cases you may have the data only of 6 months. Okay, so annual is not possible. You look at the last 2. Similarly, if you are doing it for an area which will have commercial or office, office land use, okay, or educational area, for example, okay, then I know I should focus on weekends, right? Huh? Sure? Everybody? Sure? Nobody is saying that. Okay. Weekdays, yes. You should focus on the weekdays. Okay, so it depends upon where you are doing it and how much data you have. So this value can be any of those. The point was, this value is not always AADT. Okay, it can be any of the 4. And then we have the percentage of this value in one direction. Okay, and as we said, both directions will not have the same value. So I'm looking for the peak, the one which is higher. Okay, then this is the percentage of traffic in the peak hour. This is the whole day, right? I'm not designing for the whole day, I'm designing for 1 hour. Okay, so I'm looking for the value which is the peak, the percentage of traffic which will come in the peak hour. Okay, so your daily volume, which was total of both directions, it became for one direction for 1 hour. Clear? Okay. Then how do we get these values? Obviously there are local studies being done on existing highways. So Ministry of Works has, has sensors installed at many highways, and they are collecting data. So when they collect data, then they can see in the which one is the peak hour. Okay, for example, 7 to 9 usually is the peak period in the morning. Okay, then 4 to something is the peak period in the evening. Okay, so they know these hours. Okay, and they know approximately how much percentage we can expect on different types of highways. Okay, and when they start a new project, they collect this data for few weeks. Okay, on the existing highway as well as the highways which are near that project. So they are about to construct a new bridge at a location, so they will collect data for a few days on that location as well as on other locations as well, which are connected to it. Okay, the point is they have this data with them. From that data they can calculate if I'm doing a major highway. Okay, then on a major highway the percentage of traffic in each direction is normally 60-40 or 70-30 in the peak hour. Okay, and out of the total traffic, 20% is normally in the peak hour, the remaining is distributed. Okay, so this should come from local data. Okay, this should come from local data. Okay, but these are some values which are given in the textbook, okay, and we can use them as well. So those values are depending upon the type of highway you have, okay, the K value and the D value. So this gives you the percentage in the peak hour, this gives you percentage in the peak direction, okay. Rural, suburban, urban. Somebody already mentioned that for the type of highways, right? These are different types of areas. What is the difference between these areas? Main difference.
Traffic density.
Traffic density, population density mainly. Population density is higher where? In urban areas. Okay? So it goes stepwise. Population density. Lower, then higher, then highest. Okay? And keep in mind, I'm not saying number of people, I'm saying density. So density is per unit area then. Okay? You may have the same amount of people in two different areas. Yeah, but in this area, the same number of people are living in a smaller area. So the density will be higher here. What's my point? Okay? So for example, there are many agricultural countries, India, Pakistan, where most of the population is in the rural areas. So if you count the number of people, you will find it higher in the rural area. Okay, urban area is less. Okay, in many cases. But in urban areas, their density is higher. Okay, so there are less people living but in a smaller area. This is what we mean. Okay, this is the main difference between rural and urban. Okay, so these are the factors, their ranges are given because again, they will not be same. You cannot, until unless you have the exact value which you have taken from your own data, these standards can only give you ranges. Okay, because they are approximate values. We cannot pick one value right now. Then in urban areas, we have two types of, two options here, radial route and a circumferential route. Okay, radial route comes from radius, circumferential route comes from circumference. Okay, so radius means what? Radius means what? Radius is for a curve, but radius means what? Yes? It's a line going to the center, right? Okay, from the center, right? So this is what we mean here. A radial highway goes from the center towards the edge. Okay, goes from the center towards the edge. And circumferential means what? From the edge to edge, or around the center. Okay, around the center. It goes from edge to edge, but from the center, it becomes what? Clear? Okay. So these are the options we have. For example, we have to calculate the AADT for a rural highway, and they have forecasted after 20 years the demand will be 30,000 vehicles per day. Okay, and it is AADT. So AADT means what? What is it? Okay, so this is the average of the entire year then. Okay. So based on the data from this table, we have to find out the, one thing which I forgot here. The hourly volume which we are using for design, we call it DDHV. Okay, directional design hourly volume. Directional design hourly volume. So it is in one direction, it is used for design, future, and it's hourly. Okay. So if you know the term, even AADT, ADT, AWT, if you know the term, then you know what to do with it. Okay, that's why I'm emphasizing on it. So this is for one direction. So you have daily, which is for both directions. You multiply by D, it becomes directional. Okay, it's for future, so design. And then we have hourly volume, so you have to multiply by K as well. Okay, if it is not a future value, a simple hourly volume, I ask you, give me hourly volume of this highway, then what do? You go and do it. Okay, because it's already there. It's not for future, right? This is for design. Clear or not? This equation when you are calculating hourly volume for design, which is in future. Okay, so we have to do the multiplication everything. Okay, for an existing highway, for now you will go and do it. You don't want to, but you still have it. Clear? Okay. So we are doing it for a rural highway. For rural highway, the ranges are K 0.15 to 0.25 and D 0.65 to 0.8. Okay. So this is the equation. My A value was 30,000. Okay. Now you have two options here, right? You have the whole range here. Okay. So let us try the full range. Okay, and let us see what we get. So if you take the lower values of the range, what do you get? And if you take the higher values, what do you get? Now this is not, now what, vehicles per hour. This was day. To convert to per hour, right? And this is
6,000.
okay. Any confusion here? Okay. The point to be noted here is the difference which you are getting. It's the same type of highway. I'm taking from the same range. Okay, but here you look at the difference. It's 2,000 something. Okay, 3,000, and this one is 6,000. So this is slightly more than the double of it. Okay, so this emphasizes the point of having actual rates. Okay, if somebody is just relying on the range, he can be out by 200 or 100%. Maybe he's designing for 2,900 and the actual could be 6,000. Got the point? Okay. Another thing is, you see, as I'm going from rural to urban, the values are decreasing, right? Okay. So, for example, if I take something, okay, and I have to distribute it to all of you. Okay. Let's say your grades. I have full number and I will just distribute. Okay. Now you are basically around 30. So if I give each one of you the same amount, I have to do what? 1 by 30, right? 1 by 30. It will be a very small value. Okay. But if I say no, I like this guy, I'll give him more. Okay. So for this peak guy, the percentage will be higher, right? Okay. So let's say this guy is my peak hour, or this guy is my peak direction. So if I distribute unevenly, he will get more, right? His share will be higher. Okay. And if I distribute it equally, then it will be 1 by 30, which is a lower value, right? Got it? Clear or not? Any problem? Okay. So this is what is happening here. In rural areas and suburban areas, one direction or 1 hour has substantially high traffic than the other direction and the other hours. So the proportion of that hour and that direction is much higher. This is unequal distribution. This is showing unequal distribution. Okay. In urban areas, there are very few hours in which the traffic is very low. Normally in most of the maybe 5, 6, 7, 8 hours, the traffic is normally on the higher side. So it's more equally distributed. Get my point? Okay. So when the percentage is getting lower, it is showing the traffic is getting equally distributed. Okay. Clear? Okay. Then we have the sub-hourly, meaning when you take the value for less than 1 hour, and we already said that it can be flow or rate of flow. Okay. Which one of them is per hour? Which one of them is per hour? Flow is per hour? Rate of flow. Rate of flow is per hour. Rate of flow. Flow is less than 1 hour. The value as it is. Okay? And the rate of flow, you have to make it per hour. That's why we call it the rate of flow. But going well. Forgetting in the same class. Okay. So, yeah. Now the point could be that we take this hourly volume, this one, and you start the design. Okay. You did not consider flow or flow rate. Did we do it? Did we consider what will be the flow, what will be the rate of flow in this hour? So let's say this is for 8 to 9 a.m. So in 8 to 9, I'm expecting 6,000 vehicles. Okay. Will these 6,000 vehicles come at equal intervals? So every minute I have like 10 vehicles, something like this? No, they are unequally distributed, right? To look at this unequal distribution, I need the flow and rate of flow. To look at this unequal distribution, I have to look at the flow, and I'm looking at within the hour, right? Inside the hour, what is happening? So I have to look at flow and rate of flow. Now somebody comes and says, why should I look at flow if I have to design for an hour and I have the hourly volume? Why should I bother about this? In the end, even if the distribution is more or less, it doesn't matter. The total will be 6,000. Right or wrong? Is he right or wrong? Right. Well, if you are getting F. Look at it from the point of view of structures. You have taken the course in structural design, right? Everybody remembers. Okay. So, for example, if I say the total load on this slab will be 6,000 tons, and I don't care where it is, whether it is equally distributed or whether it's a point load. I don't care. I'll just design it for 6,000 tons. Am I right or wrong? Wrong. Okay. In the same way, you cannot ignore the distribution of traffic as well, because here the distribution is in terms of space, right? Here the distribution is in terms of time. If you ignore it, that time, so if you ignore the distribution of space, what will happen? The point where you assumed less load, but it is more, although the total is same. But on that point, it is more than your assumption, or more than your distribution. On that point, it starts failing. On that point, it will start failing. Okay. So this is what happens on the highway as well. I'll just show you before we leave the class, and then we will do we will look at the solution later on. So you have the total volume 4,200. You have the value for each 15 minutes, okay, and we call it flow, okay, and each value is converted to 1 hour, and we call it rate of flow, okay. And as I mentioned earlier, rate of flow can be for each 15 minutes because the flow is for each 15 minutes. Now, if you don't consider these values, so we forget about all these rows. We look at what? 4,200. Okay. So I'm designing the road for 4,200. This is not how we do. That's just to explain the point. If you ignore the flow, what can happen? Okay. This is just to explain the point. The real process is this one. Right. This will show if you ignore the flow, what can happen. So if you design for this one, okay. So 4,200 in 1 hour. Equally distributed in all 15 minutes. How much in each 15 minutes? Tell me. 4,200 total, equal distribution. How much for each 15 minutes? 1,050. Okay. So if I go with equal distribution, my total is 4,200, and for every 15 minutes, 1,050. Okay. Now see what has happened. First 15 minutes, 1,000. Actual flow is 1,000. How much you assumed equal distribution? 1,050. Okay. Good or bad? Good. Next 15 minutes, actual flow 1,100. My equal distribution 1,050. Good or bad? Bad. So this is where the failure will start to happen. Okay. This is where you start If there's a failure in the structure, you see the cracks. If there's a failure in on the highway, you see the queue. Okay, you see the queue, the traffic jam. Okay, so this is the point where the traffic jam will start happening. Okay, the failure point. Okay, next 15 minutes. Okay, how much will be the traffic jam here? Actual was 1100, your assumed was 1050. How much is the shortcoming? 50. Okay, so this is the traffic jam I have right now. Okay, next 15 minutes, 1200. My assumed equal distribution 1050. Okay, good or bad? Bad. Bad by how much? Why 200? 150, right? Here 150. Okay, but again going to the same principle of a structure, if there's already a crack in the building and you start putting more load, the crack will open up, right? So this is the opening up of the crack now. It was already opened by 50. Now you are putting more load now. So it is opened by 200 now. Traffic jam has increased to 200. This 200 includes 150 of this and 50 from the previous one. Okay. Next, 900 applied load, 1050 assumed. Okay. Just considering this, good or bad? Good or bad? Good. Okay. Because I'm getting less than what I can handle. Okay. So now, in this last 15 minutes, I will have some extra space. Okay. Some extra space, because the number of vehicles coming are less, the number of vehicles which are going can be more. Okay. So how much extra space I got here? Huh? 1,500. One of my friends did it, and I told him, you 47,000, and it was 470,000. He was saying 47,000. I told him, what are you doing? Like, I spent half an hour doing this, and because of your, he said it's just a zero. It's just a zero. You can get it, no problem. If you want it, I can give it to you. But we got extra space of 150, right? Got extra space of 150. Who will utilize this space? Okay, because these vehicles are stuck. So whenever they will find extra space, they will move. Got it? Clear? But the problem is, I got extra space for 150 vehicles. I have how many? 200. So the 50 are still stuck. Okay. Now what was the total here? What is the total here? What is the total? 4,100. What is the total here? 4,200. Right? Did all of them pass? No. How many actually passed? 4,150, right? Now you did not reach your, how much was your capacity? Your capacity was? Did you reach it? No. Why not? Because you did not consider what is happening with the distribution. Okay? So if you just design on the basis of total, your highway will fail. In the same way, the structure will fail. Okay? The slab will fail from one point and start to fall down, and you will be thinking, no, I had the same 6-ton load. How can I fail? Or how can it fail? It will fail. Clear or not? Okay? So we have to introduce another factor to accommodate for this variation of the flow as well. Okay? Which we will talk about next time. Hawra Ahmed, Maryam Musa, Muhammad Khalid, Umayma Yasir, what?
Can I
Can you what?
Listen it.
Yeah, now you can listen. We are finished.
Really? Perfect.